Hello everyone, welcome again to another exciting video where we will continue our discussion from our previous video where we discussed building an agent from scratch with Python. The reason I decided to make a part 2 of this is I thought that I could discuss the React pattern a bit more better with the help of a nice diagram, and that would help understand the concept a bit more better. So even though I say this is a part 2, I will explain the entire video once again so that it is easy for you guys. Okay, what is React pattern? So React pattern basically means reason first and then act. So what happens in a normal LLM? You ask a query and the LLM responds based on its knowledge, whatever it has. And in real world scenarios, this is not enough, especially if you need information that is latest as of today or as of yesterday, because it is not possible that the LLM is trained with the real data set. And what's the solution? Using an agent. So what is the solution here? The solution here is to implement a process wherein the LLM does not answer immediately, but it actually tries to think about the user input question. And based on its own internal thought processes, it takes actions to give an appropriate answer to the user. Here, the agent will have access to tools from which it can access to data. It can be private data or it can be public data, or it can be any tool action wherein it can use a specific tool to perform an action. For example, let's say an image generation tool. Yeah, so it can use this tool and generate an image to the user if that user has asked this question. However, this tool must be accessible to the agent. Okay, so what is the parameters of this React pattern? The first step is thought. So we need to tell the LLM that the very first step in this pattern is that it should think about the user question. It should not immediately answer. And based on the thought process, it should decide if it has to take any additional actions. If not, then okay, fair enough, it can respond. But does it have to be one action? No, it can be multiple actions also, one or two actions. So based on the action performed, so the action is usually performed in a specific environment, which is the tool itself. So tool has an separate environment of its own based on the type of the tool, and there that action will be performed, and the result from the tool is then fed back to the LLM as an observation. So based on the observation, the LLM can decide if the user's question has been substantially answered. If yes, then it will output the response. If not, it will go back into this action loop again and then keep performing this loop. Now, it could be the case that this loop can end up in an infinite loop. To prevent this, what we will do is we will set a stop break filter where we will say, okay, if after 5 loops or maybe 10 loops, you should break this, and whatever result you have, you output this. Hope this is clear, and we will now quickly jump on to the code. Let's start with the system prompt. So the system prompt is the first prompt that will be given to the LLM to tell it what is the intention. We intend to that the LLM should behave with this React pattern. And so in this prompt, we specifically tell it you run in a loop of thought, action, pause, and observation. And at the end of the loop, you output an answer. You use your thought to describe your own internal thoughts about the question you have been asked. Use the action to run one of the actions that are available to you, and the observation will be the result of those actions, and you must output your actions in the format of action tool output name. We will have look at why this is important a little later. We will also tell it what actions it can perform. It can perform a calculate option action, an average dog weight action, and a Taveli search. This is something we had not discussed in the previous video, but this is one of the real world examples. So we have added this Taveli search. I will quickly show. This is the Taveli app wherein you can copy this Python snippet. You will need a Taveli API. It's free, so you can actually just add billing, but it will probably also, yeah, you don't have to add billing, I guess. So it's a free researcher. You get 1,000 API calls, so you can try this out. Copy this code and get a API key, and then you can use this. Okay. So we also give it an example session as to how it should actually behave specifically. You can go through this, and let's now look at how the actual agent is built. Okay. So we define the class agent and we initiate the agent with the system prompt. So this is the same system prompt that we wrote here, and we will pass the system prompt through this variable. So you save the system prompt and we define a list of messages. This is important so that the entire conversation history with the agent in the current session is saved. So this is like a short-term memory for the current session. So if there is a system prompt, we append this system prompt first. And here it is important to note that we need to tell the role here, because then the LLM can differentiate between a user question and a system prompt and the response given by the AI itself. So differentiating these roles helps the AI understand what the entire previous conversation was about, who said what, and how to handle them, or it gives a better context. Now this call function is called every time an agent is initialized with the user function. So every time you initialize the user function, you pass the system message, of course, and then you can directly call the agent with the user question directly without implementing as a separate function, and it will be passed to this call function. And here the first thing you do is, of course, since it's the user who has called the agent, you have to pass this user message and you define it as a user message, and then you execute the LLM. So here in the self.execute, you actually call the LLM in this function, and the response from the LLM is then saved again in the entire list of messages that we defined with the role assistant, so that the LLM knows that this was the response from the LLM itself. So now we come to the execute function. This is nothing but it is just calling your OpenAI API with the model, and you submit all the messages of all the conversation that has happened so far. So you were preparing this list, and then all the conversation is sent to it, and the LLM goes through it and provides its response, and then we return this response, which is then here saved or appended from this result here. Okay, hope this is very straightforward. 3 simple functions: initializing the agent, passing on the user message, and then sending that user message to the LLM itself. So this is a very basic, very simple agent function. Okay, let's have a look at all the 3 tools. These are very basic and rudimentary tools. This is an eval function that evaluates any equation that you type in as a string. It returns that answer. This is a very dummy function with average weights of certain breeds of dogs. This is just for demonstration purpose, but this is something that we can really use in the real world. This is what this agent will make really usable. This is the Taveli search client that I showed you earlier. You just pass the user question as the query, and then it will provide you, or this Taveli search will respond with the information from the search engine. We will have a look at this when we run it. Now we build a dictionary of all the known actions, and we pass in all the function names to this dictionary so that this can be passed back to the AI agent when it needs to perform the action. And finally, we implement the loop, which we discussed earlier here, the action and observation loop, along with the starting point, which is the thought process. So in this query function, what we do is we pass the question from the user and we set the max turns limit. This is currently set to 10. We can set it to 5 as well. It's fine. And we start the counter and we initialize the agent with the system prompt. And the system prompt is passed and the LLM will now know that it has to behave in this pattern of thought and action and observation. Next prompt, however, will be the actual user question. So first you initialize it with the system prompt, and then we will next pass the next prompt, that is the actual user question. So we will define this while loop with max turns limit, and then we will call the bot, which is the instant of the agent, and then we will pass the user question, which is stored in this next prompt. So we could have directly passed the question here, but this is fine. We will just print out the results for us to see how the agent is interacting. Okay, now based on the result of the first user question, which is the thought process. So first what happens is there will be a thought process when the first user question comes. So in the thought process, did the LLM decide that it has to perform an action? This is the question being asked to us. So we need to then go through the entire result. So this will be a text output and see if there is a regex match. So this is the function that we have defined here. We need to see if the LLM decided to perform an action, and this is where in the prompt we have critically mentioned that it has to output its format your actions as action tool name. So this regex function looks for this specific format so that it knows that the LLM has decided to perform an action. Okay, then it could be just one action or multiple actions. So it goes through the entire text by splitting it with the new line, and then whenever it finds an action to be performed, then it adds it to this list of actions. And if there are any actions, we will first extract the action and the action input. So again, going back here, this is the action and the tool name, and what is the input to be provided to that tool. That tool will need an input, so that also is decided by the LLM in its response. Okay, we have to check if the action being described by the agent is actually within the known actions. This is the dictionary that we defined here. If it is not, then we raise an exception. If it is, then we actually call the function. So the function is called and the action input is passed through this. So it goes and looks through this known actions dictionary, and this dictionary passes back its function. So let's say, okay, let's look at this average dog weight. So it passes this function back, and then the query will be passed here. All right. Okay, and then we will print out the observation and we will pass this observation as the next prompt, so that when the loop forwards here and it comes back here, the next prompt is then forwarded again to the bot, so that this loop then continues until the max turns is achieved, and then it exits. Hope this was very clear. And finally, let's get to the query. Let's try with a very simple query here. Let me run this. So this is how much does a toy poodle weigh? Very simple question. The answer should come from here because we have toy poodle's average weight is 7 lbs. So exactly like this, we have an observation that the toy poodle's average weight is 7 lbs, and then the answer has come out. So this is neat, very simple. Let's try something complex here. Let me pause this. And this is a very interesting question. I now want to find the weather of Munich and Bangalore together. So there are two questions in one statement. Let's see how the LLM answers or the agent answers. So let's have a look at this. So first, okay, let's scroll up, scroll up. Okay, thought. I need to find the current weather for both Munich and Bangalore. I will use the Teveli search. So it knows what search tool to use to fetch this information. So this is the first thought. So if we go back here, so the first thought was that it will perform an action. Okay, cool. And then it set out this action, Teveli search, weather in Munich. So this was the query, weather in Munich. So, and then the Teveli search actually returned the latest weather in Munich. So lot of information for the LLM to perform. Okay, thought. The next step, the weather information for Munich indicates, okay, fine. Now I will fetch weather for Bangalore. So now it takes the second action here. So it fetched the weather information for Munich. Now it knows that it still has to fetch the information for Bangalore. So it decided to take one more action, which was again Teveli search weather in Bangalore. So it got the response. Awesome. Large response. And the next thought process. The weather in Bangalore indicates, okay, combining this with the Munich weather, now I can formulate a comprehensive answer. So now it has all the information to give out the answer. So the answer is, today in Munich, the weather is around 12 degrees to 17 degrees with some rain and snow possibilities. In Bangalore, it is very hot with temperatures between 95 degrees Fahrenheit. Okay, I would have loved with degrees Celsius. Okay, 35 to 38 degrees, and there are several days of rain expected. Awesome. I hope you enjoyed this video, and yeah, thank you for watching. Have a nice day. Bye bye.